So, it's been over 3 years now, or I would say coming close to 3 years since 5G was launched in India. Airtel was first to do it. But in last 3 years, a lot of developments have happened. Quite a few innovations have happened. So, in next 10 minutes, my idea is to give you a glimpse of how the world is changing, thanks to some of the advancement in the network related area. But more importantly, if you look at adjacencies in tech world, cloud, AI, how they are all coming together to make it happen. For example, you might have seen, if you're an Airtel user, I'm sure your users, you've been a beneficiary of the fact that we provide spam prevention, fraud prevention solutions today. But not many people realize that to identify a call as a spam, potential spam call, we look at over 300 parameters within milliseconds to identify that it's a potential spam. And that requires massive cloud infrastructure, that requires massive use of network level artificial intelligence to provide that information and make it possible that those spam calls are identified clearly. We did the same for fraud prevention. For example, if you get a compromised link on SMS, in past, there were challenges because SMS essentially runs on SS7 network. It's actually not connected to the IP network. But the moment you click on the link, it actually takes you to the IP network. So the point is, when we see few innovations coming in the market, which are in time-wise in parallel with some of the network-related advancements like 5G, you would assume that 5G is making it happen. It is true, but it is also not true. Unless the advancements in cloud, advancement in artificial intelligence, all are brought together to make it happen. Those advancements do not come to life. So let me start with an example. In fact, I'll pick up an example of a customer in manufacturing space where we have made use of private 5G in manufacturing environment, where autonomous mobile robots are used today. And then obviously it's a smart factory running on private 5G. It utilizes multiple sensors, multiple video surveillance devices to make this all happen. So it does utilize some of the key features of 5G. For example, ultra reliable low latency communication is something that 5G introduced. It is very much used here because you need very, very low latency in order for an autonomous mobile robot to operate. On the other hand, you also need large bandwidth. You need multiple IoT devices to be connected. You also require network slicing because in a factory environment, you want to create right level of service level, service levels have to be provided. These robots should, because they upload a lot of data, you need dedicated bandwidth to make sure that they operate seamlessly. So these benefits are kind of tied to 5G in a huge way. It also comprises of some of the capabilities that edge computing builds in. In fact, in a factory environment, typically you would also put on-site, on-prem, cloud capability, or I would say compute capabilities, which are kind of connected with major hyper-level large cloud to make some of those technologies become possible. Now, you might also have noticed that Airtel very recently launched a large sovereign cloud for India, which means that the data plane and control plane are within the country. So I'm going to show you how possibility of some of those cloud capabilities, the AI capabilities that come along with that, including the data platform, make some of these things possible. So in this kind of environment, if you look at typical role of an autonomous mobile robot, it essentially, what it does is, it replaces some of the manual work that is done by workers, creating significant amount of efficiency, and it obviously leads to cost reduction from economic metric point of view. It also creates massive opportunity for revenue generation because now if they have a sales organization, they can on a real-time basis know what kind of production capability is being created so that they can commit right kind of quantities to customers. It requires significant amount of integration between some of the physical devices. That includes the sensors, the associated transducers. There are a lot of video devices. There is massive upload of data also that happens. And I'm talking about a real case study here. For example, in a parallel environment, I would say if you looked at tire industry, for example, not many people realize that when a tire gets manufactured, from the time it comes to life, which means it gets created and quality checks are done, where you take pictures to make sure that it has right quality, to the time it goes out of service, let's say in 5-7 years, it probably gets photographed 100 times to make sure that it is of right quality. And each of those images need to be uploaded on the system. Now, for those systems to be uploaded and analyzed, you obviously need large compute infrastructure, and most of the time it is cloud. Which also means the connectivity part has to be accurate, especially if it is on the shop floor environment. You need very low latency to make sure that the tire that is created is of right quality so that you can move on to the next tire. Now, if autonomous mobile robots are operating in that environment and creating that tire, they need ability to smoothly operate those and make sure that they upload right kind of information, which requires good infrastructure of cloud. Now, when we launched cloud, we considered many of those aspects. Obviously, it was something which we had created for our own use over a period of time. This cloud infrastructure was created to support our own operations, which is at scale. I mean, today we have, I would say, 360 million plus subscribers within the country. If I look at our Africa operations, which would be another 212, etc., we have more than 570, 580 million subscribers globally. That makes Airtel the second largest telco in the world. Now, when you operate at that scale, in order to create efficiency, you need the right kind of IT infrastructure which will support those operations. So many of those things were optimized in the process, which was brought to life when we launched our sovereign cloud. So if we look at the essential features of what we brought, it involves technology integration of more than 25 sophisticated hardware and software technologies, which allowed us to scale and created an innovation engine that we could bring to the market. It was very important that the total cost of ownership was designed for Indian markets, because essentially people go for cloud. It is not just a technology transition, it is also a business model that people go for. So that part was absolutely critical. In today's world, if you don't think of, for example, any kind of AI integration, it would be meaningless. So bringing in AI, chatbots, etc., to make sure that, the operations part is seamless was very, very critical. But we did not just look at the cloud part. We said, look, as a telco, you need to provide right level of reliability if we are going to take it to the market. So unlike other propositions, we came out with telco level reliability, which means 5 nines of reliability on the system, cutting across all cloud infrastructure, which means the core part of cloud that you're providing, whether you decide to build an edge part, we wanted to make sure that that level of reliability is there. So going back to the autonomous mobile robot case, what happens then is, as these robots navigate the factory floor and go to different environments to create efficiency, they're taking images. At the same time, you also have to do fleet management, because there's a fleet of robots now. These robots also have to take on-site decisions to decide if the quality of, let's say, the end product is right or not. At the same time, they are collecting huge amount of data that needs to be analyzed for, let's say, preventive maintenance or predictive maintenance. And some of those things require huge compute power. It requires analytics power that uses artificial intelligence, which allows these devices to take decision on the spot, but also allows them to plan for certain actions in a planned way. For example, if you're in a continuously running manufacturing plant, especially if it happens to be a process industry, you cannot actually ever stop the full operations, because the moment you stop it, restart takes a huge amount of time. And therefore, the predictive maintenance part of it, the preventive maintenance part of it becomes absolutely critical. Which means, let's say I have got a sensor connected to a turbine, which is indicating to me that probably the turbine might have a failure in 9 months' time. I need to take a decision at what point of time I should change certain components so that turbine never gets out of service. And many of those things have to be captured on a real-time basis. So the role of cloud becomes extremely important. But collecting data is not the job. Ultimately, what you want to make sure is that you take that data, analyze it using artificial intelligence and other means, and come out with inferencing information that allows you to take a decision. So when we look at just 5G enabling it, it is true that 5G is enabling it, but without a very robust cloud infrastructure, without right level of connectivity down to the shop floor, some of those things won't be possible. And as we look at these three components, one area that you can't ignore today is the cybersecurity piece. So if you look at what happens is, you need to look at the whole ecosystem around 5G that makes these products happen. You have to look at the cloud infrastructure. You have to look at the artificial intelligence part of it so that you can do right kind of inferencing. But as you packetize the network and you start connecting it to cloud infrastructure, cybersecurity becomes a problem. And unless you have thought of it at the time of deployment of the solution, it still would not come to life. For example, the separation between the operational technology, the OT part of it, and IT part of it is very, very critical. It is very important that you also segment the electrically connected devices, create them in groups so that one, at the first place, breach itself does not happen. So you take a prevention-based approach to cybersecurity. But in the event that some kind of breach happens, it should be possible to identify it and remediate it. So that micro-segmentation helps in that part of it. So in this keynote, the point I wanted to emphasize was that looking at multiple parallel developments of technologies is very, very critical for a new innovation to come to life. When it comes to 5G, it has been 3 years. In these 3 years, there have been huge advancements in cloud infrastructure. In fact, I'm very proud to say that Airtel took the initiative there to make sure that it is also very sovereign, because having the control plane within the country is absolutely critical, not just for geopolitical requirements, because geopolitics can lead to enablement or disablement of some of these technologies, but purely if you look at it from technology point of view, sovereignty is important, which means that the control plane and the data plane have to be in the country. Just a couple of weeks ago, in fact, there was a major outage in global subsea capacity, and that led to some impact on internet services. Imagine if your control plane was outside the country and that gets impacted. None of these robots will be fully operational and your predictive and preventive maintenance will be at risk. So whether you deploy 5G or private 5G for manufacturing environment for mobile robots, whether you use network slicing for first responder solution, which is where we have used private 5G, or you use it for a healthcare solution where private 5G gives dedicated bandwidth to a moving, let's say, ambulance, you have to make sure that associated infrastructure of cloud, artificial intelligence, as well as cybersecurity to protect them all is put in place. I'll leave you with this thought. Thank you.